The trap shyness issue does raise a bit of an issue, or a bit of a question of where to from here. What are the other management techniques that we can employ where we do have trap shyness? Do we change our trapping technique, or do we move on to some other focus? And Daryl would be the man who can give us some pointers on that. So, Daryl King.
What I'm going to try and do in 10 minutes is to start with the issue that we've been talking about here for much of today, which is that proportion of the myna population that is out there in big numbers, in your face, foraging, which is the target of all of our trapping and the subject of virtually all of public interest in mynas. And look at the second component of the population, which particularly in a population like Canberra, where knockdown has occurred, the population's very low density in some areas and very wary in most areas. Those birds that are not in your face, they're quietly in the background breeding away, producing the next generation of symptoms of the problem. In other words, the foraging mynas. Here's a typical example of ideal myna breeding habitat, a modern suburban settlement. There are hundreds or thousands of potential nests in that landscape, in buildings, in dense vegetation, and in places like Canberra in hollow trees, under bridges and so on. The interesting thing is that only about 1% of them actually are viable myna nests in any given breeding season. And only about 70% of that 1% actually go on to successfully produce fledglings. And about a quarter of 1% go on to breed in successive years. So they might breed 2 more years, but if they go on and breed for 3, 4, 5 years, then they become a critical refuge, a critical breeding refuge for the local myna population. And up on the right-hand side there are a few reasons as to why those nests might be successful year after year. The problem that they pose relates to the way that mynas expand in an area. Once they establish a nest which is successful in a few breeding seasons, they're in a position, they've got a base from which to prospect for new nests. And in the study that I've looked at, they're establishing new nests in a cluster around the most secure nest in the landscape. A lot of those nests won't succeed, but some of them will. And the interesting thing about the cluster is that each new nest is within communication distance of a neighbour, or maybe several neighbours, which means that their alarm system can work extremely effectively. It also means that when juveniles are dispersing, they can hear another nest or see another nest nearby, and that greatly assists their dispersal. Now, if all of those satellite nests are knocked out, the population still can maintain itself at a low density because of the value of this refuge nest. And over time, you'll find that breeding populations will slowly expand at I think Kate said earlier, or I've heard her say before, at about 0.5 kilometre per year. And this breeding mechanism is an extremely good explanation as to why that expansion rate takes place across the landscape. So it's a critical issue, and what I'd like to really think about is how communities can help one another to locate where nests are that are possible to be managed. A lot of them won't be easy to manage, but by and large, any nest in an artificial structure can be managed in a very straightforward way. It may not be easy, it might take money, it might take landholder cooperation, but it's straightforward. We already have techniques that we use for starlings and sparrows. We heard about possums and so on, and they work quite simply. Now the mynas, and so we need to know where the nests are, and the mynas actually help us in this regard. I've looked at about 2,500 records of foraging mynas, and if you look at that blue line there, that represents the average distance of a foraging myna from an active nest. That's about 122 metres. So once they've got a nest, they value it very highly and they spend nearly all their time in the area. if I add in all of the variation in the data that I looked at, which is the yellow line, you've still got all the miners in that local population, and it might be very small, spending most of their time within 250 metres of a nest. And if we turn those two arrows into the radius of a circle, you can see that that's quite a discrete, compact area to search for nests. If we know that miners are foraging in that area, we've got an extremely good reason to believe that they're breeding successfully in there. Now, I hasten to add that that's an idea of the size of the foraging range of the nest. It's not the shape. The shape's probably going to be very complex. It might be linear or some other shape. But the critical thing is the size. It's very compact. That blue circle, the average distance, contains an area of less than 5 hectares. People in that area will be aware of miners all the time foraging, but they may not yet connect that with the fact that there is a nest nearby. So there's a hypothesis that can be tested. If we know where miners are foraging, we've got a damn good idea where they're breeding. And I set out to have a look at that. At the time of year when miners are most conspicuous, when the numerous in-your-face birds are around in numbers in the second half of the breeding season, that's the time to collect your data. And while we've heard a lot about traps as a way of figuring out where miners are foraging, observation, I think, is an extremely powerful tool, and it should be added in. Both of these techniques, trapping and observation, are much easier in the second half of the breeding season because of the young, naive juveniles in the population. And to make it worthwhile, as we've heard several times today, we need to be able to identify where nests are, not just on the local scale, but on a whole landscape scale, such as all of urban ACT, which is where 99% of miners are breeding. And we certainly shouldn't be looking to invent a whole new system for finding nests. We should piggyback on arrangements that we've already got in place, such as MynaScan that we heard about earlier, but more particularly the volunteer trap network that's out there. Here's a fairly old now map of where Canberra trappers are located. But the first thing you'll notice about that is it covers the entire breeding area. And it's focused quite specifically on where miners are foraging. And because this program's been in place for 7 years, it tells us when they were foraging there. So it's potentially an extremely good database of where and when miners are foraging. And if that helps us find nests, then this trap network looks to me to be an ideal survey tool, monitoring tool. And it's ideal in other ways, as we've heard before, that everybody who's set up a trap site in their backyard knows very well what a miner looks like and what it sounds like. And because they've got a wire trap, which they may or may not be setting at the moment, they've got a scientific sampling instrument that can collect miners for them while they're off at work. So as a monitoring network for looking at foraging miners, I don't think I've seen a better one than this. It's perfectly equipped for the task. But to see whether it helps us find nests, I had a look at miner foraging and breeding in that yellow area in Belconnen. It's a typical sample of traps in the ACT, and it's also a typical sample of the miner population, very low density, 12 plus or minus 5 miners per kilometre squared, and a very wary population. 20% or more of surveys outside the breeding season, I wouldn't see or hear any miners at all. So difficult to detect, but all the more reason to have a lot of detection and monitoring power to do it. So these are the nests that I identified and studied. At that low density of nests, I estimate there was something like 50 to 55 active nests in the whole study area. I selected the 27 that I could monitor on a daily basis at the same time as I was monitoring along 100 metre wide transects where miners were foraging. So I had 2 lots of data coming in from the same surveys where are they foraging, where are they breeding, are the nests successful. And during this second half of the breeding season, I'd be surveying those transects 3 to 5 times a week. So I had a fairly good opportunity to collect data. So first question, breeding success. And I think I haven't repeated what I mentioned earlier, that these circles, these concentric circles, are the calculated foraging distances at each nest. So, and it also helps us to see where the nests are, that those circles are there. Nests that I regard as refugial because they were successful in every year of the study are shown in pink. About a quarter of them. That would be the equivalent of 15 or 16 nests in the whole study area. 2 of them over on the left-hand side are in structures, in buildings. All the rest are in hollow trees. So there's an opportunity cost there for native birds and mammals. So what does the foraging location of these juvenile groups at the end of the breeding season tell us about nest locations? This is all of the foraging groups that I saw on my surveys during the first fledging period. We'll look quickly at the other 2. They're all within breeding areas. The 2 dots down in the bottom in the creek corridor appear to be anomalies, but in fact they're on the edge of the foraging range of a nest right in the centre of that 30-hectare block, which I could hear from my transects, but I couldn't see it, so I couldn't monitor it. But probably the most telling thing is the summary down the bottom left-hand corner. The red dot there is the median position of mynas in relation to all of those nests, and that tells us that more than half of the foraging groups that I looked at in that first period were within 120 metres of a nest. That's a pretty precise indication to me by these foraging juveniles that there's a nest in that place. So what about, rather than doing transects, what if we monitored at fixed points? And these yellow dots are the registered trappers or the registered trap sites in the study area. And once again, you can see that these are in pretty good positions to identify where nests are by virtue of being able to observe that there are foraging groups in those locations. And if you look down in the bottom left-hand corner again at the summary, you can see that more than half of foraging groups and therefore more than half of nests were within 250 metres of a registered trap. At 250 metres, I can certainly hear all the loud calls at a nest, and in that position, if you're there not just flitting through at 15 kilometres an hour on the survey, but you're there day after day, you're going to see some of these birds, and if your trap's out, you may in fact sample some of them. And if we look quickly at the second fledging period, almost identical situation. Once again, you would have to say that those registered traps were in ideal positions to monitor what was happening at the nest. And once again, in the third fledging period, almost an identical situation, although the resolution between trap sites and nest sites is actually a bit better. It's about 180 metres, and that's probably largely to do with a 20% increase in the number of trap sites in the study area. So if we come back to the original question, what do foraging groups tell us about the location of refugial nests? Once again, they're the pink circles. The resolution between trap sites and nest is even better. That's less than 150 metres. There's a very, very good chance that an observer in that position is not only going to hear mynas but see them, and in the right circumstances perhaps catch some. Earlier on I said that because we've got good data on where trap sites are and how long they've been there, we've actually got a mechanism here for estimating how long refugial nests have been active. And if you look at the green trap sites, the ones I've highlighted in green, the average time that they've been out on the ground is almost 5 years. So my estimate that these refugial nests have been active for 3 years is pretty low. I think the trap sites are telling us that they've been dealing with the symptoms of these refugial nests for up to 5 years or maybe even longer. So, in summary, I'm convinced from the pilot study that this array of potential monitoring sites, not devised by NASA but self-selected by individual people who are concerned about mynas, is potentially a very sensitive monitoring tool for finding nests and for helping one another to identify where they are and to come up with management practices to deal with them. And maybe the only thing I'd add is that it's taken me 3 years to collect 2,500 data points on foraging mynas. This array, this network could collect that many data points in less than a week.
Thank you, Daryl. And I think what Daryl has pointed us to is that we can use this sort of information to hone in on where nests are. And if they are in man-made structures, in roofs and outbuildings, etc., then it really does allow us, rather than being trying to trap them, to actually get them at their nest site. And probably more difficult to climb up trees, and councils, I suspect, to be very reluctant to have endorse community people doing that on public lands. But I think it does give us something to think about in terms of moving beyond just trapping as a way of controlling mynas to actually target those refugial nests which have been repeatedly the main source of breeding. So thank you very much for that, Daryl. That's very, very good.
Daryl, you mentioned that the trappers were perhaps a fabulous monitoring resource. What sort of information would you want to get from the trappers? Would you want them monitoring bird numbers, or if you were going to design a system that could give us the most information, what would you ask of them?
Thanks, Greg. It's going to vary from place to place. In a place like Canberra, where the population has been knocked down since about 2007, 2008, the location of nests is very clear, and I think all you would need to do is to ask trappers, not necessarily to trap, if it's up to them whether they want to trap or not, but to keep a diary during the breeding season, and either feed directly to one of the databases like MynaScan, or alternatively to Central Point like SciMag. Very simple question, have you seen any foraging groups, or have you trapped any mynas in at your location during the current breeding season? Now, you might be able to ask the question in a more sophisticated way, but my feeling would be to minimise the load on trappers. I mean, a lot of people have put their traps away and heaved a sigh of relief that they don't have to do what's generally a pretty unpleasant activity. They're satisfied that mynas are no longer visiting their backyards by and large, but they're still interested. They still notice mynas in their neighbourhood. They still talk to one another about mynas. But keep it simple. Just remind people at the beginning of the breeding season that at the end of the breeding season, you would like to know whether they've seen juvenile groups in their area, or whether they've trapped any juveniles in their area during that current breeding season. It could be as simple as that, because to my eye, the indication that a juvenile foraging group gives you of the location of a nest is so precise, and the density of trap sites in Canberra is so good that in the single breeding season you're going to have enough data just by asking that simple question that allows you to say, these look like priority areas. If we also knew where all the hollow trees were, and we don't, and I think that's something we should be ashamed of, we would then be able to make judgments about whether that particular refugial nest is going to be straightforward to manage or not. If they're in hollow trees, they're not straightforward. If they're in any kind of artificial structure, we already know what to do and we should be doing it, but we need to know where they are.
Look, from 2009, you guys had the big cell, etc. Made it very easy for my councils such as myself to start a program. For example, for councils who haven't started a program, who are keen, and I can see the fault with the HIMAG is that we haven't done our initial data. So I guess that's the next step for the Hawkesbury area, is to do the data. So I guess what I'm requesting, do we want groups who haven't started anything yet, they should be doing data, and if so, they should, I guess, try to follow a holistic model. And I guess, is there an information pack out there, what type of model of data capture to do?
I think what Martin's pointed to is that, as one of the earlier members of the audience mentioned, is that there's a fair bit more that we can do to help both local councils and community groups go through the process, understanding what the elements of a good control program is, monitoring, advice about the characteristics of mynas and why some of those characteristics do help control programs. So more for us to do collectively, and a lot more for local councils to do.